Okay, topic N16 is more quadratic word problems. We're going to look at some area type problems. Okay, remember the formula for area is length times width. And this example is going to show putting a fence around all four sides of a rectangular area. Okay, so depending on how much fencing you have, okay, two sides are always going to be the same. So if the width is x, okay, then you take the total amount of fencing you have, subtract 2x, and divide it in half, and that'll tell you how long you, or how much fencing you have left to put on the other two sides. So we're going to use that relationship to write a quadratic equation. Suppose you want to build a pen for your dog. You have 500 feet of fencing material. Okay, we need to find the area of this dog pen. And if we look down here, it says, what is the maximum area? Okay, so really what that means is we're looking for the vertex. Okay, and we know that the vertex can be found by using the formula negative b divided by 2a. Since these numbers are really big, rather than graphing it on the calculator and zooming out a bunch of times, we're just going to get right to the point. We're going to figure out where the vertex is immediately. Okay, let's go back up to the top again. Okay, area equals length times width. Okay, the length, I have 500 total feet of fencing to use to build this. So 500 minus 2x divided by 2, that represents the length only. I have to multiply length times width. Okay, if I simplify this expression a little bit, it'll look a little nicer. 500 divided by 2 is 250. And 2 divided by 2 is 1. Okay, and then if I distribute the x, then it's going to look more like a quadratic equation that you're familiar with. 250x minus x squared. Okay, so I'm going to look at it like this. A equals negative x squared plus 250x. And I want to use the formula negative b divided by 2a. B is 250, so negative 250 divided by 2 times a, which is negative 1. So negative divided by negative turns into a positive, and 250 divided by 2 is 125. Okay, so remember that this is the formula for x. Okay, x equals 125. Okay, what does that mean? What have I done here? Well, remember, that's the axis of symmetry. Let's move that over a second. Okay, the axis of symmetry is going to be right in the middle of your parabola. So if x is equal to 125, let's plug x back into our equation to see what, how high up this parabola is going to go. Okay, that's a pretty big number to want to do in your head, so let's just go ahead and plug that into our calculator. Okay, store 125 in x. Okay, and now I can just type out my equation, 250x minus x squared. That's the equation we came up with for area. Okay, so the vertex, the maximum area, it's going to go up to 15,625. Okay, whenever x is 125, the maximum is going to be 15,625. Okay, so over here was 250 because that's what we divided by 2. Okay, the roots were 0 and 250. So this is what your parabola would look like. Okay, the function f of x is equal to negative x squared plus 250x. Okay, the domain from 0 to 250. So we're going to go from 0 to 250. Okay, the range is going to go from 0 to 15,625. All right, let's use the information we found to answer a question. What is the maximum area? Well, that can be found at the vertex, okay? And the y-axis is measuring the area. So 15,625 square feet. And the next question, what are the dimensions? The dimensions are the length and the width. Okay, we'll look at the graph. X is measuring the width. Okay, and if you look back at our description of the length, it says 500 total feet of fencing minus 2 times x divided by 2. That's going to tell us how long the rectangle is. So 500 minus 2 times 125 divided by 2. That's 500 minus 250 divided by 2, which is 125. Okay, so if x is 125, let's say that a little differently. When the width is equal to 125 feet, the length is equal to 125 feet as well. Okay, so the dimensions would be written like 125 by 125. Okay, another way to look at area, a second scenario, if you would, is if we're only going to fence 3 sides. This side over here, let's say that it's sitting up next to a building of some type, so you don't need a fence around it. Okay, it's still going to be the same situation. We're just not going to divide it by 2, because in this case, we only have that one side there. Okay, so we're going to take the total fence, subtract 2 x's, and that's going to leave me with the amount that I can put along that longer side. Okay, so let's look at how much total fencing we have. Okay, suppose that a storage building will form one side of the pen so that you will not have to fence that side. Assume you are still using 500 feet of fencing. Okay, so we're going to take what we know is the area formula, length times width. And the length is represented by the total fencing, which is 500, minus 2x, times the width, which is x. So if we put that together, we have 500x minus 2x squared. And we'll write it like this, negative 2x squared plus 500x. Just rearrange it a little bit. Okay, that way we can tell what A, B, and C are. Okay, so x, we're going to look for the highest point, the vertex. Okay, x is going to equal to negative b, and b is 500, so negative 500 divided by 2 times a, which is negative 2. Okay, that's negative 500 divided by -4. So x equals 125. Okay, remember we're looking for on the x-axis. X is measuring the width. Okay, and using the formula for the vertex, we just found out that the vertex is going to be at x equals 125 feet. Okay, so I'm going to plug that one into the calculator. 125 store x. Okay, my function is -2x squared plus 500 times x. Okay, so the vertex is going to go all the way up to 31,250. Okay, and don't forget that my other x-intercept was 250 there. So I'm going to go up and then down. Okay, the function f of x equal to -2x squared plus 500x. Okay, the domain is going to go from 0 to 250. And the range is going to go from 0 to 31,250. What is the maximum area that can be enclosed? Okay, back to the graph a second. The x-axis was measuring the width of the rectangular area. The y-axis is measuring the area. So if you want to know the maximum, just look at the vertex. That's your maximum area, 31,250 square feet. Okay, what are the dimensions which will give you the maximum area? Well, we know when x equals 125, we get the vertex, the maximum. Okay, so we're going to plug that back into the description of the rectangle at the beginning. Okay, 500 minus 2 times 125. 500 minus 250 equals 250. So the length is going to have to be 250 on this one. Okay, so the dimensions are length 250 by width 125 feet. Both of those are in feet. Okay, and one thing to talk about too, if we're going to graph this, the window needs to go from 0 to 250 on the x-axis and 0 to 31,250 on the y-axis. So 0 to 250. And we're going to just erase that scale there. Put 0 to 31,250. Okay, and erase that scale. Go to y equals -2x squared plus 500x. Graph. And we didn't even have to zoom out or anything. So what we did by finding the vertex right away using the formula, we were able to graph this parabola without trying to zoom it out.